Very good morning, friends. We have dealt about various forms of chemistry, starting from inorganic chemistry, organic chemistry, heterocyclic chemistry, medicinal chemistry, and so on and so forth, polymer chemistry, and whatnot. Today's subject of discussion is green chemistry. What is this green chemistry? Whether we prepare an heterocyclic compound or an organic compound or a polymeric compound or any type of material, we use chemical synthesis. To synthesize the particular type of chemical, we use enormous types of solvents, reagents, reactant, and whatnot. All the chemicals which we use are harmful not only to our health but also to the environment. This green chemistry is all about preventing this pollution caused by these chemicals such that we can sustain the earth environment. This is green chemistry. Why this green chemistry emerged? When it got emerged, it emerged after the passing of Pollution Prevention Act 1990. We use enormous amount of chemicals, types of chemicals, which is hazardous to nature. Not only nature, it is also hazardous to human beings, to lives. Thus, to make the synthesis environment friendly, the concept of green chemistry came into existence. It is something like we synthesize a drug molecule to cure particular disease. To synthesize that molecule, if you pollute the environment, then what is the use of treating or producing the drug to treat the disease? For example, I have synthesized a drug to treat asthma. And asthma, we know that is due to one of the reason is the pollution in the environment. To synthesize a particular drug to treat asthma, we pollute the atmosphere and create asthma. There is no point in creating or synthesizing that molecule to treat that particular disease. The father of green chemistry is Paul T. Anastas. He is the person. The philosophy behind the green chemistry is reduction of pollutants or treatment of pollution by preventing the formation of pollutants. Instead of creating pollutants and then treating it before disposal, making environment friendly and make it to dispose, it is better if we prevent. It is something like prevention is better than cure. Thus, the green chemistry has a role to play today. Green chemistry is utilizing the set of principles. By using these principles, it reduces, if not, it completely eliminates the use or generation of hazardous substances during the course of design, manufacture, and application of chemical products. It seeks to reduce the pollution at the source. It is something like tax deduction at source. Our government deduct our salary at the source as tax. The same way, we have to deduct that formation of pollutants. Green chemistry deals with the reduction or formation of pollutants, whereas environmental chemistry focus on the study of these pollutant chemicals and their effect on the nature. Green chemistry is all about reducing the formation of waste or creation of waste, reducing the usage of materials, the starting materials what we are using, the reagents we are using, the reactants, the solvents, all causes some amount of pollution. If we can reduce the material usage, means if we can increase the yield by creating a synthetic route such that by using little amount of the starting material or reactants or solvents or so on, it also contributes to the protection of the environment. Lesser the uses of the material, lesser the pollutant formation, lesser the pollutants formed, lesser will be the impact on our earth. As far as possible, reduce the usage and generation of hazardous materials during the course of synthesis of compounds. Reduce the risk while synthesizing the molecules or compounds. And efficient use of energy, reduce the usage of energy. If my reaction takes 12 hours, it requires more energy to be given. If I complete that reaction in 1 hour, I have reduced. It is something like power saved is power generated. Energy saved is energy generated. It decreases the pollution in turn. Reduce the cost. And also, finally, reduce the environmental impact by reducing all the above things. Green chemistry follows 12 principles. The principles of green chemistry are like this. The first principle is prevention of formation of waste. The second principle is the waste formation reduction by maximum utilization of atom economy. All the reactants and the reagents utilized in the course of the chemical reaction will be utilized fully to form the product, no byproduct formation. Here, by utilizing the atom economy, we can prevent the waste and use less hazardous chemical substances or produce less hazardous chemical substances. Is another principle of green chemistry. And user of safer chemicals. Instead of using methyl iodide, I can use dimethyl sulfate. Methyl iodide is carcinogenic. Dimethyl sulfate is a safer chemical. And use of safer solvents. Instead of using benzene, wherever by possible, I can avoid it and use toluene, which is less hazardous or less carcinogenic than benzene. And increase the energy efficiency is another principle of green chemistry. Means instead of carrying out the reaction for 12 hours, if I complete in 1 hour, the energy is saved. That's why I increased the energy efficiency. The seventh principle is instead of usage of Non-renewable stock, feedstock, we can generate by using renewable feedstock instead of getting the chemicals required as raw materials by the petroleum products. Get that products by using the natural products which are renewable in nature. Fossil fuels is non-renewable. It exhausts. As far as possible, reduce the chemical derivatives, protection, deprotection, wherever it is necessary. Only we have to do. As far as possible, you have to reduce the chemicals derivatization. The reaction can be hastened up by using the catalyst. Design of chemicals and products such that the chemicals and products which are formed are biodegradable. We have to synthesize those chemicals which are biodegradable or easily degradable. And the another principle is development of analysis of the substances formed in real time online during the course of formation such that we can prevent the pollutants formation, and also minimizing the potentials for accidents. Chemistry lab is the most dangerous lab if at all we are not utilizing it properly. These are the 12 principles on which green chemistry works upon. Let us discuss one by one. Prevention of waste or byproducts. What is waste? The waste material may be the starting material which has not fully reacted, unreacted starting material, or entrapment of solvents which are used can be a waste material. The major product what is formed and the byproducts are the one which is not intended for us, whether it is required or not, it is formed. We have to prevent the usage of these things, then we will reduce the environmental effect of the pollutants. If this waste is discharged, it causes pollution. The waste which is formed, if I treat and then dispose, it won't create problem to environment because we have treated it, mild it, and then we are releasing into the atmosphere. But it increases the cost. In decreasing the cost is one method, is prevention of the formation of waste. Prevention is better than cure. That's why this is the procedure followed. As far as possible, prevent the formation of waste. If it is not possible to prevent at all, minimize the formation of the waste. This formation of waste should be minimal. We should create a synthetic route such that minimal waste is formed. Instead, where the byproducts, if at all possible, it can be, if it can be reused, the catalyst can be reused. The starting material which is unreacted that can be separated and reused if possible, so that there is no waste product formation. Recycle it and reuse it, and use it the energy more efficiently. If nothing occurs, then disposal by treating is the last alternative. This is the first principle of green chemistry. Prevent the formation of waste or byproducts. If cannot prevent it, minimize it. If possible, reuse it and recycle it by utilizing the energy more efficiently. The second principle is maximum use of materials that are used in the chemical reaction. That is nothing but atom economy. The reaction is considered green when there is maximum incorporation of all the starting materials and the reagents into the final product. Ideal situation is one where the starting material or reactant amount what we use equals to the amount of product formed. Which there should be 100% results. 100% conversion is possible. But however, in reality, many of the times it is not possible. In that case, what we have to do? Can we improve the method to reduce the formation of waste or to increase the formation of the product required? That is atom economy. Percentage of atom economy is given as 100 into relative molecular mass of the desired products but divided by relative molecular mass of all the reactants. Now, I will give with one example. I can oxidize benzene in the presence of oxygen. 1 mole of benzene utilizes 4.5 moles of oxygen to give maleic anhydride, carbon dioxide, and water as byproduct. The molecular weight of maleic anhydride is 98, molecular weight of benzene is 78, oxygen 4.5 moles. I use oxygen 16 into 2 32, 32 into 4.2 is 144. The percentage of atom economy if I calculate it is 44.1% if I use this method. The atom economy is only not more than 50%. Because carbon dioxide, water, it's okay. It is environmental friendly. Carbon dioxide, when it is released, it increases the heat. It contributes to the global warming. That's why alternate method is I can oxidize butene which utilizes 3 moles of oxygen to give maleic anhydride and water. Water is the byproduct found which is bio-friendly or environmental friendly. Here we are created a route of synthesis in which the carbon dioxide, which is environmental non-friendly chemical, is not formed. And if I see the atom economy, molecular weight of butane is 56, oxygen 32 into 3 96, the molecular weight of maleic anhydride is 98. If I calculate the percentage of atom economy, it is 64.5. From 44 to 64, 20% increase of atom economy I can achieve. You have to design the route such that maximum product is formed. The best one is we can see tertiary butanol. I treat with HCl, I'll get tertiary butyl chloride and water as the byproduct. Here the atom economy, if I calculate, is 83.7%. I take 2 bromo propane and treat with tertiary butoxide. It undergo elimination reaction to give corresponding propene, tertiary butanol and potassium bromide. The molecular weight of propene is 42. The molecular weight of tertiary butoxide, potassium tertiary butoxide, if I use, it is 112. If it is the 2 bromopropane 122, autonomicum is only 17.9%, and this is not environmentally benign. Atom economy is not achieved in this case. That's why this kind of reaction should not be done as far as possible. Addition reactions like diene and dienophile reacts together to give a adduct, a cyclohexene. There is 100% atom economy. Claison's rearrangement. where the product is formed from the starting material by just shifting of electrons. Here also, there is shift of electrons. 100% atom economy is achieved. By and large, every time it is not possible. Whenever possible, utilize it. All the 12 principles cannot be incorporated in one synthetic route and achieve the green synthesis. At least 2, 3, or 1 is of the principle is achieved. That is green chemistry. Minimize the usage of or production of hazardous or toxic chemicals is the third principle. Wherever practicable, use the synthetic method such that there is no generation of hazardous chemicals or toxic chemicals, not only to the people, also to the environment. I can take benzene and can also take glucose. I can convert both to adipic acid. Benzene is carcinogenic. I can use benzene and get adipic acid. I can use glucose and get adipic acid. Which is more better? Definitely it is glucose, which is environmental friendly. As a usage of hazardous chemical, instead of using benzene, use glucose. Minimization of usage or production of hazardous substance or chemical toxic substances is the third principle of the green chemistry. Design of safer products. The products which we form should be safer, means it should be easily degradable. When it degrades, it should not create pollutants. It should be designed to get the desired effect while minimizing their toxicity. The best example is the thalidomide. Thalidomide was a drug. It was introduced in the year 1961 for used in the treatment of in pregnant women for treating the or lessening the effect of nausea and vomiting, that is morning sickness. This had teratogenic effect, that's why it has been banned in the market. But however, it was introduced in the 90s to treat multiple myeloma. This produces its effect by strengthening the immune system such that the body fights with the cancer cells. It has also found its use in the treatment of erythema nodosum leprosum, an immune mediated complication of leprosy, by blocking the action of certain natural substances that cause swelling. Thalidomide to use in pregnant women, it is not safer. But as an anti-cancer drug and an anti-leprotic drug, it is safer. Because this that's why we have to design the product to affect the desired function. Thalidomide should not be used for treating the nausea and vomiting during, but it should be used for treatment of multiple myeloma. Use of safer solvents is another alternative. Wherever possible, use the solvents which are more safer or more environmentally benign. We use solvents not only for carrying out the reaction, we also use solvent for separating during chromatography, for purification techniques. As far as possible, reduce the usage of solvents. Instead of going for column chromatography for purification of the compounds, go for recrystallization wherever possible. Many of the traditional solvents what we use are highly toxic, like benzene is carcinogenic. Wherever possible, avoid the usage of benzene. Use toluene instead. Is toluene not carcinogenic? Definitely. It is not as toxic as benzene. The green chemistry approach involves, instead of using this organic solvent, use supracritical carbon dioxide as a solvent. Give better reaction. If possible, instead of using organic solvent, use water as the solvent. Almost many of the times it may not be possible because the starting materials may not be soluble at all. But wherever possible, use water as solvent. It is a philosophy. It can be done by utilization of our knowledge. Instead of using organic liquids, you use ionic liquids. These are excellent solvents for many starting materials, as or many of the starting materials are soluble in these ionic liquids, and these ionic liquids are recyclable. Why to use solvent? If possible, you do the reactions without using any solvent. This is the greener chemistry approach. The sixth principle is design for energy efficiency. Energy requirement for chemical process. It should be energy utilization should be minimized as far as possible for not only environmental impact but also for economic impact. How to conserve the energy is a principle of green chemistry. Wherever possible, use catalyst, hasten up the reaction process, reduce the reaction time. That's why the energy consumed is reduced. If possible, wherever, use microwave heating system rather than conventional heating system. The one which takes 1 hour, it can be completed in few seconds or few minutes. When microwave do not work out, use ultrasound for making the reaction. All reactions may not be possible, but some reactions are possible. Wherever possible, utilize it. Instead of using the conventional heating system, use solar energy and do photochemical reaction. Next class, we can deal with other principles of green chemistry and its achievements. Till then, have a nice day. Thank you.